So I've been running Cassandra and prod for a while. I've burned my hands and my teammates' hands, and they burned my hands. We hurt each other a lot with this thing. Because people put stuff in prod, don't know how Cassandra works, me included, and bad things happen, and then we learn. So this talk is about that. All right. So in Cassandra, you do not normalize anything ever, right? So coming from a SQL background, if you normalize, you're doing it wrong. It's almost universally true, so don't do it. Denormalize all the things all the time. And the reason you can do that is because disk is cheap, so just use the disk. All right, if you don't learn anything from this talk and you forget all of it, this is the one thing I want you to remember. CCM, Cassandra Cluster Manager. It's on GitHub. Look at it. So if you have a Cassandra deployment, a lot of times the documentation is not clear, you don't know what you're doing, Stack Overflow is not clear, there's very little information, but you have a feature that you need to do. How do you know you're doing the right thing? Cassandra Cluster Manager. What this thing does is it tweaks the memory settings and other settings for your Cassandra, so you could run a bunch of nodes locally and you could try stuff. So the way you know that you're doing something wrong is if you look at the logs when you make requests to queries against your Cassandra cluster, and you see the network traffic spike between the nodes, right? So try to do it with like, okay, here I'm hitting it by a key, which I know should be fast, or I'm doing this other query that I want to try to figure out. And if you see network traffic go nuts, you're doing it wrong, and it will break once you hit over a certain volume in prod. Do not find out about it in prod. Use Cassandra Cluster Manager so you don't have to wake up in the middle of the night because your nodes are no longer responding and your queries are all failing because it's saying it can't find a local quorum. Don't be that guy. This guy. Don't do that. All right. So a little bit about how Cassandra works. There's something known as a partition key. So the partition key is analogous to a primary key, but it's not a primary key. It's a different database, different problems that it's solving. Things are not the same. So, but this one is actually close. So partition key is kind of like your primary key in SQL, right? You use that key, you query by it, it's unique, you get your data back. All right? So Cassandra, right? So you don't, one more thing I should say, you do not go into a distributed world if you can help it. If your data fits on SQL and you don't have to go there, don't go there. You're just creating problems for yourself. So let's say you have a bunch of Cassandra rings, right? Your data, your key gets hashed and ends up in one of those rings. So when you query by it, your system internally hashes it and finds the right ring where your data resides, so you get it from there, right? Okay, so you could have multiple keys when you design your Cassandra cluster. The first key is the partition key. The second key is the clustering key. So you have your primary key, right? But the secondary key is the sort. So it's kind of like an order by in SQL, right? So you can have multiple of these keys. So your data, you could find it by key 1, right? Or you could find multiple data by that has, well, no, just you find your data by key 1, and it's sorted by key 2. So clustering key equals sort. All right, so in this second table, so you can have compound keys, right? So your key K1 and K2, right? Those two keys make up your primary key together. So they hash together, they go to a node, you can get data from that node. Your sorts are like K clustering 1, K clustering 2, K clustering 3. Those are like your order bys, right? So you can set, so it's order by column, K cluster 1, K cluster 2, K cluster 3, right? So you can do that, you can get multiple entries back and you can figure out the sort order. All right, wide rows. So Cassandra is not like SQL, right? Most SQL tables that I've seen don't have more than, let's say, 7 columns. The limits for Cassandra are quite beyond that, right? So all data can fit on, so you have to just have about enough data to fit on a disk on one machine at one time for one column, or for one row, right? So you can have a 2 gigabyte column and have 2 billion rows in that one, 2 gigabyte row with 2 billion columns in that one row, right? So in practice, I've never seen 2 billion columns in one row because that's crazy, but you could have hundreds, right? You can have hundreds of rows. They're sparse, so they don't all have to be populated. So you can have 1,000 different permutations, and you could only use, let's say, 200 of these columns, right? It doesn't take more space if there's no data in that column. So you can model around that. I don't have time to get into that, but that's a feature you should be using if you're not using it now. Wide rows are good. All right, immutable data. So in SQL and other databases that only work on one machine, usually your data shouldn't be immutable because you don't have space to store all of it, right? Imagine all your customer record changing, right? And every time you change it, you just replace it, right? Because there's a constraint. In Cassandra, it's okay. You've got a ton of space. Chances are if you're using it for the right reasons, you're not doing it wrong. You have a bunch of nodes that have terabytes of space. You're fine. So you can afford to have your data be immutable and it will work better. You're not going to have read repairs and all that other crap. All right, so the not so great, right? If you have a fake customer data, right, with 100 columns, and you have a customer ID, right, and then there's some foo bar, blah, 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 right? So that's not so good because in order to update that, you have to go get 100 and put some data on there. So you keep overwriting the customer ID 100, right? Just kind of like SQL. The better version is put a timestamp, or better yet, time UUID type. So if you have two events that happen in the same millisecond, they don't overwrite each other. But for clarity, I put in a timestamp here, right? So you can have your customer ID, something happened, you put in the same customer ID with a timestamp and updated data. Same thing for customer 200 and 300, right? So you could keep track of counters this way. So you could kind of treat it as an audit log. This makes things a lot easier to debug because you can go back in time and see how a customer looked like. Or if you're, let's say, dealing with something that you need to add up, like let's say finances, which you probably shouldn't do in Cassandra, but let's say you did, right? You can then scan the ID and figure out all the debits and credits, right, and add them up. The only problem with that is if something gets too big, right, like you don't want to scan, a million entries since the beginning of your account being open at a bank, right? You don't want 10 years of that. So you could checkpoint it. Like you could have a job at night that runs every couple of weeks, right? And it checkpoints, it adds everything up and adds a record, right? So you'd know that your logic would know it doesn't have to go and scan the entire range if that's a problem you think you'll have. All right, that's it. Thank you.